when we talk about going from phrases in English to expressions in math, basically all we're saying is we want to tell stories in the math language. We mentioned before that we can write expressions and use variables, and anyone that understands, basic math or is fluent in that language will understand what you're talking about. So let's look at a few examples on converting basic English phrases to math expressions. It'll make solving problems a lot easier. All right, so a few keywords that we'll notice here, starting with the first one. X decreased by 12. Well, decreased, you can think of, that's just subtraction. So X decreased by 12. X minus 12. Plug in a number if you're not sure. Make X 100. 100 decreased by 12. Well, that's 100 minus 12, which is going to be 88. So X decreased by 12 is just X minus 12. The sum of X and 2. So sum is another word for addition, or it's the answer to an addition problem. So the answer of adding X and 2 would be another way to say it. Well, that's just X plus 2. The product of A and B. Well, the product, or product, the word, is the answer to a multiplication question. So the product of A and B means just multiply A and B. And we can write it like this. We can write it like this. We probably don't want to write it like this, just because that looks like an X, and we're going to be using variables a bunch now, X being the most common one. So not that this is wrong, it's just, it might be kind of confusing since we have an X in there and we didn't mention it as a variable. So you want to go with one of these two over here. All right, the quotient of 42 and Z. So quotient is the answer to a division problem. So 42 divided by Z would be another way to express that. So 42 over Z. And we want to write it like this versus 42 divided by Z. You hardly will see that division symbol the further along in math you get. So writing it as a fraction is the best way to do it. All right, so keeping on. 4 times the sum of a number and 17. All right, so let's just read that again. 4 times the sum of a number and 17. So I probably want to do this part first. The sum of a number and 17. Well, since they don't tell us what this number is, let's just call it X. It's a variable. It can be whatever we want, but since we don't know exactly what it is, let's just call it X. So this number and 17, we're finding the sum of those two things. So the sum of a number and 17 is X plus 17. And then we're doing 4 times that sum. So we'll do 4 times whatever we get there when we sum those numbers together. All right, the difference between twice a number and 9. So difference is subtraction, like we saw before. The difference between, so we're going to subtract two things, twice a number and 9. So again, we don't know what this number is, so it's a variable. We could call it X, Y, Z, P, N, M, doesn't matter. We'll just stick with X. So we're finding the difference between twice, which is 2 times a number, so the difference between 2 times X and 9, and that's it. N less than P. So these ones always kind of confused me, so I like to just plug in numbers. So instead of N less than P, maybe I'll say 10 less than 44. Well, what is 10 less than 44? Well, that would just be like saying 44 minus 10, which is 34. So if I just group these variables with the numbers I used for this example together and just replace them over here, I would then have P minus N. So substituting numbers in for your variables if you're not quite sure what they mean, it's a good way to check and see if your thought process is right. All right, the quotient of X and Y. all decreased by W. So we mentioned that quotient is the answer to a division problem. So we want the quotient of x and y. So we'll do x divided by y, or x over y. And then all of that decreased by W. Not too bad. All right, we got some more here. Let's see, half of x. All right, of in math means to multiply. Whenever you see the word of, go straight to multiplication. More often than not, at least. And so we're doing half of x. So we could write this as 1/2 times x. Or we could write it as 1/2 x in parentheses like that. And if you know how to multiply fractions and whole numbers together, we could write this as x over 2, because taking half of something is like cutting it in half or dividing it by 2. So either of these options would work. Again, of typically means multiply in math. And again, we have that here, 3/4 of m. You just have to know that 3/4 means 3/4, so we can do 3/4 times m. We could do 3/4 parentheses m, or we could write it as 3m over 4. Either of these work. All right, 1/5 of the sum of t and p. So we're going to take 1/5 of the sum, or whatever we get when we add t and p. So I'm going to put that in parentheses, because we're not taking 1/5 of t and then adding p. We're taking 1/5 of the sum. So we could write that, we don't have to have the multiplication dot there. We can also write this as 1/5 times t plus p, like that. Either one's fine. All right, the difference, so subtraction, instantly go to subtraction because I see difference. The difference between 5 multiplied by x, so maybe I can write this as 5x, when we don't have any subtraction or addition or division or even that multiplication dot between two terms, if they're just sitting next to each other like that, that just means multiplication. So the difference between 5 multiplied by x, that's 5x, and 11 multiplied by c, so 11c. And that's it. Okay, here's some more real-world situation type scenarios. So the first example, find the cost per person of a dinner, D, it costs D dollars, split amongst N people. All right, so let's say the dinner costs $100. And then there are, let's say 5 people. So N is equal to 5 people. Well, how much would it cost per person? Well, we would take the cost of the dinner and then divide it by the number of people, and you would get $20 per person. So again, if I go back and I plug back in D and N, where I put those numbers to start, the 105, I would get D divided by N. So whatever the cost of the dinner is, and however many people are there, if we use this expression, we will get the cost that each person has to pay for the dinner. All right, find the total cost for renting a surfboard for a fee of $20 plus $10 per hour for X hours. So just think of this scenario. You're going to go to the surf shop and you want to rent a surfboard. They're going to say, okay, well, you got to pay us $20 up front. We don't care if you just rent the board and walk around with it and pose. But you're going to pay $20 regardless of whether you take it into the water or not. And then for however many hours you hold on to that surfboard, you're going to pay $10 on top of that initial $20 that you gave us. So we're going to give this surf shop $20, and then we're going to give them $10 for every hour that we spend renting it. So 10 times X. And plug in numbers if it doesn't make sense. Let's say you rent it for 4 hours, right? You're going to pay $20, and then you're going to pay $10 for the first hour, plus $10 for the second hour, plus $10 for the third hour, plus $10 for the fourth hour. And that's going to give you 40 plus the initial 20, which is 60. And if we take 4 and plug it into our variable that represents the number of hours you're renting this surfboard for, well, we can do 10 times 4, which again is 40, and then plus 20 will give us the $60 for this rental. All right, couple more here. If H represents Bill's height in inches and Sue is 6 inches shorter, write or what expression will give Sue's height? So if H is however tall Bill is, and Sue is 6 inches shorter than that, let's say he's 60 inches tall, well, she's going to be minus 6 inches that, which is 54 inches. So we called 60 inches, that's Bill's height, and then we are subtracting 6 inches from that, so H minus 6 will do the job. All right, if Ted, Jed, Larry, and Mary donate some money that will be split evenly between X people in need, how much will each person in need get? So maybe we can call, they don't give us a whole lot here, but let's just come up with our own variables in this situation. There's nothing preventing us from doing that. We could say T is the number of dollars Ted gives, and then J is the number of dollars Jed gives, and then L for Larry and M for Mary, right? And they're putting this all together into some pool of money that's going to be split. So we'll add that up. So that's all the money that they donated. And if they decide to split it between 2 people in need, well, we're going to take this and then divide it by 2. If they decide to split it up between 10 people in need, well, we're going to divide that total up that they donated by 10. So whatever the number of people in need that they're going to get to split up this money is, well, we're just going to take the sum of all the donations and divide it by the number of people. And there we go. That's it.